Hi everyone. In this video, we're going to talk about chapter 15 about hydrocarbons, which is alkene and alkenes. We will discuss about the general reactivity of alkenes and the reactions for alkenes such as combustion and free radical substitution. Also about how cracking can be used to obtain more useful alkenes and alkenes. This is the fourth learning outcomes. Okay, let's start with the classification of hydrocarbon. Hydrocarbon can be classified into two types, which is an aliphatic or an open chain carbon, okay, such as alkene, alkenes, alkynes. Yeah, you can see that the first C and the last C not connect each other, so this is called as aliphatic or acyclic or open chain hydrocarbon. While if the carbon connected one another and make a cyclic form, it is called as carbocyclic. Okay, for aliphatic, hydrocarbon can be divided into alkenes if all contain single bonds, alkenes if there is double bonds, and alkyne if there is a triple bond. For carbocyclic, there are two classes, which is the first is alicyclic. Alicyclic, that means the carbon-carbon chain, yeah, make the ring, and the ring not conjugated. Yeah, the ring consists double bond or no double bond at all. And if it is consists a double bond, the double bond has not conjugated each other. Okay, so it is called as alicyclic. Alicyclic can be divided into three, which is cycloalkenes. Okay, like this only. Cycloalkenes, there is double bond, maybe one or two. For cycloalkynes, that's triple bond. Yeah, but this is rare. For aromatic, it is cyclic, but it has a conjugated double bond. Conjugated, that means the double bond and single bond adjacent each other. Okay, and then that means the double bond can be shift from one position to another position. So this is called as aromatic, yeah, and can be symbolized by the ring inside it. Okay, aromatic, that means consists of benzene ring. So that's the differences between aliphatic and carbocyclic or and aromatic. Okay, we will focus on alkenes. Yeah, in this video, we will focus on alkenes and alkenes. To understand about alkenes more, we will learn about the general formula, the source, and the reactions of alkenes. Okay, the general formula of alkenes, as you know, is CnH2n plus 2. So, all alkenes should follow these rules. Yeah, so for example, if we have one C, so the formula for alkenes is CS4. We know known as methane, ethane, yeah, etc. Okay, not all single covalent bonds and display sp3 hybridization since single covalent bond, so there is no other hybridization, yeah, only sp3. This means that alkenes have the maximum number of hydrogen atoms, so known as saturated hydrocarbons. Okay, since it is saturated, yeah, it is unreactive. This is how we represent alkenes. Okay, the 3D formula, the display formula, the structural formula, and this is the scatter formula. Icosane is a straight chain alkene whose molecules contain 20 carbon atoms. What is the molecular formula of icosane? And draw the scatter formula. So Cn S2n plus 2. So C20H42. This is the molecular formula and the scatter formula. Yeah, you just draw like this, yeah, until 20. Yeah, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Yeah, just like that. Okay, so after the general formula, we will learn about sources of alkene. Alkene source is crude oil. Yeah, it found trapped in layers of rock. And you know that crude oil is a complex mixture, yeah, of hydrocarbons such as alkenes, cycloalkenes, and aromatic compounds. Okay, you know that cycloalkenes has ring, so they can be separated using fractional distillation like this. As you know that the lower relative MR, yeah, more volatile, so it will come first. Yeah, so these, yeah, will be obtained, yeah, at the lower temperature. They have they have increase of the boiling point, yeah, as the number of carbon increases. So you can see here that this process called as fractional distillation due to the different boiling point. Yeah. Okay, this is the main point about reactions of alkenes. Since alkenes is a very unreactive compound, yeah, since they have only single covalent bonds and no other electronegative atom inside this molecule. So once again, this is inert, unreactive. So only several types of reactions that can occur in alkenes, which is combustion, substitution, and one more is cracking. Okay, but cracking is more to industrial process. So we just focus on these two, combustion and substitution. Okay, and then you know that alkenes is a non-polar compounds. That means alkene will not react with water. Yeah, since yeah, it is non-polar. Okay, the hexane which is dyed with iodine to make it clearly visible. Yeah, at the top at the top of water. Yeah, since it has a less density compared than water. They do not mix and they do not react with each other. Okay, so we call these two solvents as immiscible solvent. Immiscible solvent, solvents that do not react each other. Combustion of alkenes produce energy, so that's why alkenes use for fuel, right? Petrol, LPG, LNG, etc. Because once again, combustion of alkenes produce energy, and you know that every combustion reaction needs oxygen. So you can see that the equation of combustion reaction is CXSY with O2 to form CO2 and H2O. This is the products of combustion. Yeah, if we expect it is occur in excess oxygen, that means the complete combustion occur. Okay, this is energy released by combustion of methane. This is negative 890, 190, while gasoline C8, yeah, octane negative 5,500 something. Yeah, so very large energy release. Okay, let's see this practice question. The complete combustion of 2 moles of a straight chain alkene produces 400 dm cube of carbon dioxide. Measured at this pressure, CO2 can be assumed behave as ideal gas. What is the formula of the straight chain alkene? Please try and pause this video while you're working. Okay, everyone, are you done? Okay, if you're done, you can check your answer with mine. Yeah, we don't know the formula of the alkene, so assume this is CXSY. I will make the equation first to show the combustion reaction. Okay, I have 2 moles of alkene, the straight chain alkene, and it produces 400 dm cube of carbon dioxide. Okay, this is 400 dm cube. Okay, I have pressure and temperature. Okay, and then this is state that this is ideal gas CO2. So I can use PV and RT. I like to find the moles of this gas. Okay, so PV over RT, 1 times 10 to the power 5 Pascal times volume should be in m cube. So how to convert the m cube to m cube? Yes, divide by 1000, yeah, or times 10 to the power -3 m cube. What is ideal gas constant? 8.314. Okay. Okay, and then for the temperature is already in Kelvin. So now use your calculator to calculate this. Okay, the result is 16 mole. Okay, and you know that the mole ratio, yeah, can be represented by the coefficient ratio. So since we have 2 moles of CXSY and 16 moles of CO2, I can assume this is the moles ratio, so it's 216, yeah. So I will put here, yeah, as the coefficient. Okay, then let's calculate the number of C at the left hand side. We have C equals to 2x, right? And at the right side, C equals to 16. So x equals to 8, right? So this alkane consists of 8 carbon. What's the general formula for alkene? It is CnH2n plus 2. So if we have 8C, then the number of hydrogen would be 18. Okay. So what's the answer? It is A.